Hello guys, welcome to the next class. In this class, we'll discuss about logarithms. Now, logarithm is a very important thing. It will be used everywhere. Even direct question are asked in G Advanced from logarithm. So, for the people who are starting the 11th class, this is a very important thing for them. So, let us see now, guys. How do we see this logarithm? First of all, we have this a power x equal to n. To understand logarithm, first we see what is a power x equal to n. Here a is called as base number. We take a only greater than 0. Why only greater than 0? Because negative numbers cannot have every power. If I say minus 2 and power I take as 1 by 2, minus 2 power 1 by 2, which basically which will become minus 2 square root. You see it is not defined. So negative numbers are not defined for every power, so we take a only positive. Next, a should not be equal to 1. Why? Because if a is equal to 1, you get 1 power x, which is always equal to 1. So it will be a constant function only. So we need not study that also. And n should be greater than 0. N should be greater than 0 because whenever you raise a positive number, let us say 2, to some power, say 4 or minus 2 or 0, every time the final number will be positive. In this case, you get 16. In this case, you get 1 by 4. In this case, you get 1. So for a positive number, take any power, positive or negative, the final value will always be positive. Okay, so first you just understand a power x equal to n. We refer to this as exponential function. Exponential function. A will be a fixed number here, x will be changing, and with the different values of x, n value will also be different. Conditions are a is uh, basically a is called as base, and conditions on this are it should be greater than 0 and not equal to 1, and the final value n should always be greater than 0, will come out to be greater than 0. Now, what is this relation with the log? How do we write the same thing in the log is this? It is just this thing we write in log as we say log base a n is equal to x. That is all. If a power x is equal to capital N, then we say log base a of capital N is equal to x. This is what you have to remember. If you remember this thing, every question of log, every property of log, we can do it. So how do we see log here? If we have log base a n is equal to x, it simply means a power x is equal to capital N. Okay, so they both are same things. If this is given, you want to convert into this form, we say we take log. And if this log thing is given, you want to convert into exponential, we say we take anti-log. That is all. If you remember this condition, just this and this are equal, everything on log we can solve. Okay, let us try a few examples. This is solve for x. You have to find the value of x, and what is given? We have given that log base 2 of x is equal to 4. So if log base 2 of x is equal to 4, what will be value of x? You see, this is given, we have to convert into this form. When this is given, log thing is given, you convert into exponential, you'll get the value of x. So what do we do here? We take anti-log. We take anti-log. So when we take anti-log, what we discuss here? So you get 2 power 4 will be equal to x. Here base power x was equal to n. Here base is 2. This side we have 4. So we say 2 power 4 is equal to x. So x will be equal to 16. That's all. I hope you understand, guys. Try the next one. See, next we get 243. Here when you take anti-log, you get 3 power 5 is equal to x. Try next one. Here we get answer to be 4. We get half raised to power minus 2 is equal to x. So half raised to power minus 2 is equal to x. Then x will come out to be 4. I hope it is clear, guys. In the third problem, the base is half, which is allowed. You see, no, base greater than 0, not equal to 1. But between 0 and 1, it is possible. And the right side, if you see in this log thing, I gave you right side to be x. Now, there is no condition on x here, this x. You see, x can be positive or negative. The condition is on n here, this n, which in this problem is this x. So the right side here can be negative and the base can be between 0 and 1. When you find the value of x, x value will always be here positive in this case. I hope it is clear, guys. This is a basic understanding of log. Now let us go to the properties. These properties are very, very important. There are some 9 properties and every question will be based upon these properties only. Okay, so first of all, if you just see the properties, we'll discuss proof of few of them. You have to make note of all of these properties, then only you'll be able to solve problems. The first property is log base a of a is equal to 1. We'll discuss the proof of them also. For now, just see all of them. Log base a of 1 is equal to 0. Third, log base a xy is equal to log base a x plus log base a y. Next, log base a x power n is equal to n time log base ax. How do we see this thing? This power we say comes outside. If we have log base a x power n, this power n is on x only. So this n comes outside. Next, log base a x over y is equal to log base a x minus log base a y. The next, we call this as base change property. If we have base a here, log base a of b, you want to change the base to some other number c. We have log base c of b by log base c of a. Okay, so you want to convert it to base c. So write both the logs into base c. In the numerator we put b, in the denominator we put a. Next, if you want to interchange base and the number, so log base a of b will be 1 by log base b of a. Eighth, if we have a power log base b of c, you see this a and c can be interchanged. So you get c power log base b of a. And the ninth one, log base a power n of b power n. So what will happen? The b will come outside in the numerator and the n will come outside. Sorry, the m comes outside in the numerator and the n comes out in the denominator. So you get m by n log base a of b. Okay, these are the 9 properties, guys. You have to write them down or somewhere because these are very, very important. All the questions will be based upon this thing. In mains, advanced, directly the things will be used. Let us see some proof of them. So I'll discuss first one here first. So log base a of a is equal to 1. This we have to prove. Let us assume log base a of a is equal to x. And if we take anti-log, we get a power x equal to a. If log base a of a is equal to x, then we discuss anti-log will be a power x is equal to a. And if a power x is equal to a, x has to be 1. So from here we can conclude that log base of a is equal to 1. Using same logic, you can prove the second property also. Let us go to the proof of third one. In third one, we have to prove that log base axy is equal to log base ax plus log base ay. So what we'll do is we break this proof into small parts. So first is log base a of xy, we take as p, and when I take anti-log, you get a power p is equal to xy. This anti-log we are doing. Log base A x equal to q, we assume. So when we take anti-log, we get A par q equal to x. Then take log base A of y is equal to r. When we take anti-log, we get A par r equal to y. Now you multiply this and this. If you multiply x and y, you get A par q into A par r. X into y from the first equation is A par p. And right side you get A par q into A par r, which will become A par q plus r. And from there we can conclude p is equal to q plus r. This is what we had to prove, no? Because this we assumed to be p, this was q, this was r. So they come out to be equal. I hope it is clear, guys. Same we can prove fourth and fifth also. So I'll go to the sixth one now. You don't need to care too much about the proofs. The proofs will not be used anywhere. It is just for your understanding how we get them. At the end of the day, if you know the properties, you can solve every problem. So even if the proofs are like some proofs I have discussed, you are not able to do the other proofs on your own, you can leave them, no issue. At the end of the day, if you know the properties, you can solve every problem. So just quickly go through the proofs and then we'll do the problems. The base change property, log base A of B is equal to log base C of B by log base C of A. First of all, assume that log base A of B is equal to P. Okay, and take anti-log, you get B is equal to A par P. Take log base C of B as Q. Take anti-log, you get B equal to C par Q also. And log base C of A is equal to R, so A will become C par R. Now put A from third equation to first equation. So A from third equation is A par CR, and you can put it here. So you get B is equal to A par P and A is C par R, so you get C par R par P. So B will become C par PR, and from second equation B is equal to C par Q also. So if you compare these two, C par PR equal to C par Q, then PR will be equal to Q, that means P is equal to Q by R. This is what we have to prove from here. Okay, now seventh proof we can do with the help of sixth one. Let us go to the eighth one now. Eighth one is a bit tricky. See guys, we have A par log base B of C. You have to prove equal to C par log base B of A. First, let us assume A par log base B of C is equal to P. Now we take log base B both sides. You see, if I take log base B both sides, this thing will get log base B of this same thing again, and right side will be log base B of P. Now using that fourth property or the fifth property once again where we take power and outside. Fourth property, yes. Using the fourth property where we take power and outside, so it is like A par something. So we can take this power outside the log using the fourth property. So this power is log base B of C, and then what we are left with only log base B of A is equal to log base B of P. Let us just say this thing to be K for now. So you get K is equal to log base B of P, and then again if you take anti-log, you get B par K equal to P. Okay, just leave it as first equation. On the right side, C par log base B of A, we take as Q, and then we take log base B both side again. So log base B of this whole thing is equal to log base B of Q. Again, this power will come outside. You get log base B of A, log base B of C is equal to log base B of Q. This is nothing but K again. If you see, this is what we assumed as K. So from here you get K equal to log base B of Q. So B par K is equal to Q also. Here B par K was P. So from these two we can see that P is equal to Q. Hence proved. I hope it is clear, guys. Again, like I told you, the proofs are just for your understanding. They are not used anywhere in the problem. So even if you're like you're not able to do the other proofs yourself, not an issue. Just go to the problems. You just need to see how do we apply the properties. That is more important. One extra point here, guys. See this. If you have log x, you see no base is mentioned here, then by default in mathematics, the base will be e. So we write log x or log base ex, or even you will see ln x. ln x we read as natural log. So natural log also basically means the base is e. So wherever you see log x, log base ex, or ln x, they all mean the same thing only. The base in all of them is e. What is e now? E is an irrational number. Its value is 2.71 approximately. E is exponential number whose value is approximately 2.71. This is what you need to know right now. Okay, I hope guys the basics are clear here. What is logarithm? How do we solve the problem of logarithm? And what are the properties of logarithm? Now we start the problems. First of all, we have some true false. See guys, there are five true false you have to solve. First is log 12 is log 3 plus log 4. You just have to tell me that if it is true or false. Next, log 50 is equal to log 2 plus 2 log 5. Third, log 1 plus 2 plus 4 is equal to log 1 plus log 2 plus log 4. Fourth, log 1 plus 2 plus 3 is equal to log 1 plus log 2 plus log 3. Fifth, 1 plus log base 10 of 2 is equal to log base 10 of 20. So these five equations are there. You have to tell us if they are true or false. Basically, this given equation is correct or not. You can pause and give it a try. Let us start this question. The first is true, second is also true, third is false, fourth is true, fifth is also true. How you can see them? First one, log 12 is log 3 plus log 4. Directly third property we can use. Log x plus log y is log xy. Obviously true. Second one, log 50 is log 2 plus 2 log 5. This will also be true. We can use the third and fourth property. 2 log 5 we can also write as log 25 using the fourth property in the reverse order. So this power comes outside, so power can go inside also. So this 2 can go to the power of 5. Then log 2 plus log 25, when you add them, you get log 50. Obviously true. Third one is apparently false because on the left side you get log 7. On the left side you get log 7, but on the right side now, if you have log 1 plus log 2 plus log 4, when you add them, the numbers will be multiplied, no, using the third property. You get 1 into 2 into 4, which will be log 8. So right side we get log 8, left side we have log 7, so they are not equal, so it will be false. Next, fourth one. Log 1 plus 2 plus 3 is equal to log 1 plus log 2 plus log 3. It looks like third one, but in this case it will be true because when you add them, you get 6. And here when you multiply the numbers 1, 2, 3, again you get 6 only. So this will be log 6, this will also be log 6. So this will be true. And the fifth one is also true. How we can say that? This one, the one we can write as log base 10 of 10 using the first property plus log base 10 of 2. And you add them, you get log base 10 of 20. So this is also true. I hope these basics are clear, guys. Let us go to the next problem. Okay, first I'll discuss few 4 or 5 questions I'll discuss here, and then you can try the practice problems. The second problem we have, even if you want to try, I'll just give you some time. Second problem is 2.75 raised to power 1 plus log base 2.75 of 10. So we can give it a try, then we'll start discussion. Let us start now. The answer for this problem is 27.5. How do we see this thing? See, we have 2.75, 1 plus something. Power is 1 plus something, so we can break the power, no? If I have a power b plus c, I can write as a power b into a power c. So I'll write here 2.75 power 1 and 2.75 power log base 2.75 of 10. Now this 2.75 as it is outside here, you remember we can interchange these numbers. So 2.75 and the 10 we can interchange. It will become 10 power log base 2.75 of 2.75. And log base 2.75 of 2.75 will be 1 using the first property. So it will become 10. Just 10 power 1 will be 10. Here 2.75 when you multiply you get 27.5. I hope it is clear all of you guys. Next. Next problem is solve for x. We have 3 into x power log base 5 of 2 plus 2 power log base 5 of x is equal to 64. You have to find the value of x. Give it a try. Pause the video. Let us start discussion. See, we have 3 into x power log base 5 of 2. Here we can interchange 2 and x using the 8th property. So we got x raised to power log base 5 of 2. So here we have 3 time of something, here we have 1 time of that thing. So when you add them, you get 4 time x power log base 5 of 2 is equal to 64. So divide by 4, you get x power log base 5 of 2 equal to 16. Again, we can interchange 2 and x. So you get 2 raised to power log base 5 of x equal to 16. 16 is nothing but 2 power 4. So we get log base 5 of x is equal to 4. So log base 5 of x equal to 4. And now you can take anti-log, you get 5 power 4 is equal to x. So x will be equal to 625. I hope it is clear, guys. Next. In the next problem, simply they're asking the value of this thing. We have log base 3 power 4 of 27 power 15. Log base 3 power 4 of 27 power 15. Give it a try. Let us start discussion now. First of all, we can directly use the ninth property here. This 15 will come outside in the numerator, 4 will come outside in the denominator. So get 15 by 4 log base 3 of 27. And 27 we can write as 3 cube. So get 15 by 4 log base 3 of 3 cube. Again, this 3 can come outside. You get 45 by 4 log base 3 of 3. And log base 3 of 3 is just 1. You get 45 by 4. I hope it is clear to all of you guys.